So let's work a problem with light, or electromagnetic radiation. We'll work this one together and then I'll turn you loose for this one. So we're dealing with actually red light, and red light has a frequency of 4.75 times 10 to the 14th hertz. Red light is traveling at a speed of light. And we're going to go ahead and use we'll go 3.00 times 10 to the, 8th? And units would be, how fast is it going? Meters per second. That's the speed of light. It's the speed of red light, it's the speed of radio waves, it's the speed of gamma rays, it's the speed of electromagnetic radiation in air. Okay, so this is the frequency, and we're supposed to come up with the wavelength of red light in meters, which sounds like kind of fun, doesn't it? So we know that velocity of any wave is equal to frequency times the wavelength. We know that we can divide both sides. Let's see, we're going for wavelength, so we're going to divide both sides by frequency to get wavelength by itself. Wavelength then is equal to velocity divided by frequency. So let's go ahead and plug in. So I got wavelength is equal to velocity, 3.00 times 10 to the 8th meters per second divided by frequency, which was 4.75 times 10 to the 14th hertz means per second. So I'm going to go ahead and cancel my units. We have units of meters, which is awesome for wavelength. I went ahead and did this ahead of time, what my calculator displayed, and this you're going to get some chance at using scientific notation. Now on your test I won't use scientific notation. I will specifically avoid it, but take a look at it. So my calculator displayed 6.31578 something like that, times 10 to the -7th, and units we said were meters. Now, the rounding wise, the fact that I actually gave this the speed of light an extra couple zeros, actually I have 3 digits up here. Of course I have 3 here. That gives me 3. So I'm going to keep these first 3 digits. I'm going to truncate it right there. So since this is a 5, I'm going to have to round that 1 up. So then the answer would be 6.32 times 10 to the -7th meters. There you go. Well, that's pretty small. Fraction, a fraction, a fraction, a fraction of a meter. Okay, so I'm going to turn you loose with this one. Now, before I turn you loose, let's just double check what we got here. Instead of visible light, we're dealing with radio waves. But remember that they're both forms of electromagnetic radiation that both travel at c, the speed of light. So the velocity for working this problem is going to be that 3.00 times 10 to the 8th meters per second. That's your hint there. In this case, given this wavelength, you're supposed to come up and say what the frequency is.